Welcome back to the Comptia Network Plus course. High Availability, First Hop Redundancy Protocols, FHRPS, work by giving you a way to configure more than one physical router to appear as if they were only a single logical one. This makes client configuration and communication easier because you can simply configure a single default gateway and the host machine can use its standard protocols to communicate. First hop is a reference to the default router being the first router or the first router hop through which a packet must pass. So how does our redundancy protocol accomplish this? The protocols I'm going to describe to you do this basically by presenting a virtual router to all of the clients. The virtual router has its own IP and MAC address. The virtual IP address is the address that's configured on each of the host machines as the default gateway. The virtual MAC address is the address that will be returned when the address resolution protocol request is sent by a host. The hosts don't know or care which physical router is actually forwarding the traffic, as you can see in figure 1011. So you can see in figure 1011, I suppose here be like the cloud, the internet, and here your routers, virtual router, and here's your gateway. It's the responsibility of all the redundancy protocols to decide which physical router will actively forward traffic and which one will be placed in standby in case the active router fails. Even if the active router fails, the transition to the standby router will be transparent to the hosts because the virtual router identified by the virtual IP and MAC address is now used by the standby router. The hosts never change default gateway information, so traffic keeps flowing. Next, we'll explore these two important redundancy protocols. Hot standby router protocol. This is by far Cisco's favorite protocol ever. Don't buy just one router, buy up to 8 routers to provide the same service and keep 7 as a backup in case of failure. HSRP is a Cisco proprietary protocol that provides a redundant gateway for hosts on a local subnet, but this isn't a load balanced solution. HSRP allows you to configure 2 or more routers into a standby group that share an IP address and MAC address and provide a default gateway. When the IP and MAC addresses are independent from the router's physical addresses on a virtual interface not tied to a specific interface, they can swap control of an address if the current forwarding and active router fails. But there is actually a way you can sort of achieve load balancing with HSRP by using multiple VLANs and designating a specific router for one VLAN, then an alternative router as active for VLAN via trunking. Virtual Router Redundancy Protocol, VRRP. This also provides a redundant, but again not load balanced gateway for hosts on a local subnet. It's an open standard protocol that functions almost identically to HSRP. I'll come through the fine differences that exist between these protocols. Hot Standby Router Protocol, HSRP. Again, HSRP is a Cisco proprietary protocol that can be run on most but not all of Cisco's router and multi-layer switch models. It defines a standby group, and each standby group that you define includes the following routers: active router, standby router, virtual router, and the other routers that may be attached to the subnet. The problem with HSRP is that with it only one router is active and 2 or more routers just sit there in standby mode and won't be used unless a failure occurs. Not very cost effective or efficient. Figure 1012 shows only one router is used at a time in an HSRP group. The standby group will always have at least two routers participating in it. The primary players in the group are the one active router and one standby router that communicate to each other using multicast hello messages. The hello messages provide all of the required communication for the routers. The hellos contain the information required to accomplish the election that determines the active and standby router positions. They also hold the key to the failover process. If the standby router stops receiving hello packets from the active router, it then takes over the active router role as shown in figure 1013. So here we have our routers here, cloud. So FA01, FA00, 10.0.0.1 active virtual router, FA01, FA00, 10.0.0.2 standby, IP 10.0.0.100, 10.0.0.0.10. As soon as the active router stops responding to hellos, the standby router automatically becomes the active router and starts responding to the host requests. Virtual router MAC address. A virtual router in a HSRP group has a virtual IP address and a virtual MAC address. So where does that virtual MAC address come from? The virtual IP address isn't that hard to figure out. It just has to be a unique IP address on the same subnet as the hosts defined in the configuration. Sorry, now I'm after losing where I am. But the MAC addresses are a little different, right? Or are they? The answer is yes, sort of. With HSRP, you can create a totally new, made-up MAC address in addition to the IP address. The HSRP MAC address has only one variable piece in it. The first 24 bits still identify the vendor who manufactured the device, the Organizational Unique Identifier or OUI. The next 16 bits in the address tell us that the MAC address is a well-known HSRP MAC address. Finally, the last 8 bits of the address are the hexadecimal representation of the HSRP group number. So here you can see again, this router isn't active, this one is. So there we go. Let me clarify all this with the example of what a HSRP MAC address would look like. 0000.0C07.AC0A. The first 24 bits 0000.0C are the vendor ID of the address. In case the HSRP being a Cisco protocol, the ID is assigned by Cisco. The next 16 bits 07.AC are well-known HSRP ID. This part of the address was assigned by Cisco in the protocol, so it's always easy to recognize that this address is for use with HSRP. The last 8 bits are the only variable bits that represent the HSRP group number that you assign. In this case, the group number is 10 and converted to hexadecimal when placed in the MAC address, where it becomes 0A that you see. You can see this MAC address added to the ARP cache on every router in the HSRP group. There will be the translation from the IP address to the MAC address as well as the interface on which it's located. HSRP timers. Before we get deeper into the roles that each of the routers can have in a HSRP group, I want to define the HSRP timers. The timers are very important to HSRP function because they ensure communication between the routers, and if something goes wrong, they allow the standby router to take over. The HSRP timers include hello, hold, active and standby. Hello timer. The hello timer is the defined interval during which each of the routers send out hello messages. Their default interval is 3 seconds and they identify the state that each router is in. This is important because the particular state determines the specific role of each router, and as a result the actions will take within the group. Figure 1014 shows the hello messages being sent out, and the router uses the hello timer to keep the network traffic flowing in case of failure. The timer can be changed, and people used to avoid doing so because it was thought that lowering the hello value would place an unnecessary load on the routers. This isn't true. With most of the routers today, in fact, you can configure the timers in milliseconds, meaning that failover time can be in milliseconds. Still keep in mind that increasing the value will make the standby router wait longer before taking over for the active router when it fails or can't communicate. Hold timer. The hold timer specifies the interval the standby router uses to determine whether the active router is offline or out of communication. By default, the hold timer is 10 seconds, roughly 3 times the default for the hello timer. If one timer is changed for some reason, I recommend using this multiplier to adjust the other timers too. By setting the hold timer at 3 times the hello timer, you can ensure that the standby router doesn't take over the active role every time there's a short break in communication. Active timer. The active timer monitors the state of the active router. The timer resets each time a router is in the standby group receives a hello packet from the active router. This timer expires based on the hold time value that's set in the corresponding field of the HSRP hello message. Standby timer. The standby timer is used to monitor the state of the standby router. The timer resets anytime a router in the standby group receives a hello packet from the standby router and expires based on the hold time value that's set in the respective hello packet. Okay, so I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.